Hi, my name is Jenna Shapi, and I will be talking about hypothesis testing within business analytics. To start, most of us are probably aware of what a hypothesis is, but let's review. A hypothesis is an idea used to explain why a certain thing has happened or what could happen under certain conditions. Hypotheses are typically within an if-then format. If this happens, then this will happen. As stated by Harvard Business School, hypothesis testing is the statistical means of testing an assumption stated in a hypothesis. The specific methodology influence depends on the nature of the hypothesis and the data that is available. Sample data is typically used in hypothesis testing to get insight on or about a larger population. Hypothesis testing allows companies to test their theories and assumptions before putting them into action. There is always a risk when trying something new, and this allows for a company to verify if the analysis is correct before committing their resources towards their strategy. The hypothesis being tested in hypothesis testing is known as the alternative hypothesis. It's typically shown through the correlation or statistical relationship between multiple variables. Null hypothesis is used to show that there is no statistical relationship between the tested variables. Essentially, it is the opposite of what's stated in the alternative hypothesis. When a scenario is done multiple times, you are likely to receive close but different results each time. You can put these results in a graph, which will then give you the tallest point, which is the most likely outcome. To understand the results given in the graph, you need to identify the p-value for the test. The p-value presents the probability that if the null hypothesis is correct, results can be observed that are at least as extreme as the results of the hypothesis test done. The smaller the p-value is, the more likely the alternative hypothesis is correct. The two most common hypothesis testing methods are one-sided and two-sided tests, also known as one-tailed or two-tailed test. When testing your hypothesis, you want to make sure you use the correct method to fit your data. When you are less confident in the direction of change, you would want to choose the two-sided method. Therefore, if you have a strong conviction about the direction of change that you expect to see, you would use the one-sided method. A sample of data is needed to perform the hypothesis testing. To collect samples, you can take surveys, observational studies, or experiments. A survey is when a series of questions is asked to a random population sample with recording the reported responses. Observational studies involve someone to observe a sample population and collect data as it occurs. This is a natural, non-controlled environment. To conduct an experiment, you would divide a sample into groups, keeping one as the control group. For the non-controlled groups, the variable in question is studied and manipulated to determine how the data collected differs from the control group. Here are a few picture examples of hypothesis testing. In the first photo, the big one on the left, you can see it states the steps in hypothesis testing. Number 1, state the hypothesis. Number 2, identify the test statistics and its probability distribution. Number 3, specify the significance level. Number 4, state the decision rule. Number 5, collect the data and perform the calculations. Number 6, make the statistical decision. And number 7, make the economic or investment decision. It does give examples as a two-tailed test versus a one-tailed test. And then if you look to the top right picture, it's an example of p-value being used. And then the bottom picture, very small, but it shows the differences between null hypothesis and alternative hypothesis. When using such statistical methodology, it doesn't guarantee that we can always answer our questions. More precisely, there are errors that can occur during the process, which include type 1 error and type 2 error. Type 1 error is when we reject the hypothesis, but it is actually true. The probability of committing such an error is called the significance level. Type 2 error is when we do not reject the hypothesis while we should. The probability of not committing a type 2 error is called the power of the test. Type 1 errors can be controlled by adjusting the significance level accordingly. There are different tools to perform power analysis to decide if the data we have contained has enough evidence to perform the test. Thank you for listening to my presentation. These are my citations.